Welcome to another training session on PLC programming. One of my subscribers have requested me to make a ladder logic on how to record the minimum, maximum and the current values of an analog input coming from the temperature sensor. Means that let's suppose if we have a water tank and we are heating this water for a specific time. So in this time we should be able to detect how much the maximum temperature goes, how much is the minimum temperature in this particular time, and what is the current temperature of this water tank. Before going further in today's session, I would really thank all of you guys for supporting this channel and putting up some lovely comments under my videos. This means a lot for me and keep me motivated and keep me energetic to make more video content for you guys. In case if you are new to this channel, do subscribe and press the bell icon to stay connected and get the notification for the newly uploaded video tutorials. Let's discuss the program for the today's tutorial. In the network number 1, we will move the value 0.0 degrees to the maximum temperature register. So whenever the bit M0.0 turns on and on the rising edge, we have a move command. This move command will move 0.0 degrees temperature reading in the MD20 data register. So this data register will be holding our maximum temperature reading. Why we move 0.0 degrees into this MD20 maximum temperature data register? Because this is the minimum value temperature transmitter can detect. In the network number 2, we will move the 120.0 to the minimum temperature data register. So similar way, whenever the M0.0 start record bit is on and on the rising edge, we have a move command. It will move 120.0 or maximum temperature range of the temperature transmitter that we are using today. This move command will transfer this 120.0 degrees into the MD30 minimum temperature data register, and this data register will be keeping the record for minimum temperature value. So we will close our network 1 and network 2. In the network number 3, we will detect the maximum temperature. So the logic is really simple. As you can see that we have a M0.0 start record bit and a comparison command. So this comparison command will compare two values. Our current temperature value, which is coming into the MD10, and the maximum temperature data register, which is MD20. So as we know that we have moved 0.0 into the maximum temperature data register already. And when we turn on this start record bit M0.0, it will start comparison between these two data registers. For example, at that moment our temperature is 15 degrees. So this 15 degree is more than 0.0 degrees. So what will happen that this comparison instruction result become true, and we have a move command here. So what it will do, it will move our current value of 15 degrees into the MD20 data register. So as these two data registers are same, this value will be updated here 15 degrees. So now both are same, and let's suppose that after some times the temperature again increases and reaches to 20 degrees. The 20 degrees temperature is more than the 15 degrees value which is in the maximum temperature data register here in MD20. So this again, our comparison command will again become true, and again it will activate this move command. So again it will move the current temperature, which is 20 degrees, into the maximum temperature data register, and the same will be updated here as well. So after some time, let's suppose that our temperature drops to 18 degrees. So what will happen? This 18 degrees is less than the 20 degrees, and this comparison command will stay false, and it will remain 20 degrees as a maximum temperature value in the MD20 data register. Now in the network 4, we will detect the minimum temperature. As we know that we have started the process, and at that time we shifted the 120 degrees in this MD30 data register, and when we started recording, our temperature was 15 degrees. So as we know that the 15 degrees is less than 120 degrees, So this comparison instruction becomes true. As we are using less than comparison instruction here to detect the minimum temperature, this instruction becomes true and it will move this 15 degrees into this MD30 minimum temperature data register, and same will be updated here as well. Now our minimum temperature is 15 degrees and it will stay there, and let's suppose that after some time the temperature drops to 10 degrees. Now the 10 degrees is again less than the 15 degrees, so this comparison instruction will again becomes true and it will again move the 10 degrees value into the minimum temperature value. So as you can imagine that now our minimum temperature reading will be 10 degrees and here it will stay 20 degrees, and here in the MD20 maximum temperature data register the value of the maximum temperature will stay as the 20 degrees. Now we will upload this program into the PLC and let's see how it does works. As you can see that as we turn on the start or record bit M0.0 on the rising edge, it will move a 0.0 temperature reading in the maximum temperature data register MD20. And in the network 2, it will move 120.0 temperature reading in the minimum temperature data register MD30. Next, if we open the network 3 and network 4 and monitor the ladder logic, right now the maximum temperature and the minimum temperature is 27.35 degrees, as the current temperature is at 27.35 degrees and not moving up and down. Let's change the current temperature value to the 30.51 degrees. As you can see that the maximum temperature is also changed 30.51 degrees, as comparison instruction compares the 30.51 and 27.35 degrees, and as 30.51 is greater value, the comparison instruction becomes true, and move instruction moves the current temperature value 30.51 to the maximum temperature data register MD20. Now if we change the current temperature value to 31.65, as you can see that our maximum temperature reading is updated as 31.65 in the MD20 data register. Now let's decrease the current temperature value to 27.52. As you can see that the current value of the temperature is now changed to 27.52 degrees, but the maximum temperature value is saved as 31.65 degrees in the MD20 data register. Next, in the network 4, the current value is 27.52 degrees and the minimum temperature is recorded as 27.35 degrees. This is because as we initially started the program at 27.35 degrees temperature. Now let's decrease the current temperature to 25.61 degrees. As you can see that 25.65 is less than 27.35 degrees previous low temperature, and less than comparison instruction becomes true, and move instruction has moved the new low temperature reading 25.61 in the minimum temperature data register MD30. Now let's decrease the temperature reading to 24.31. As you can see that our logic is working perfect and the minimum temperature data register MD30 is updated as 24.31 degrees. Now let's increase the current temperature value to 50.21 degrees. As you can see that the current temperature is 50.21 degrees, and as the current temperature is greater than the minimum temperature reading, so this time the comparison instruction result remains false and the minimum temperature reading remains as 24.31 degrees. In the network number 3, you can see that the maximum temperature data register MD20 is also updated as 50.21 degrees, and as the current temperature has increased to 50.21 degrees. So this is how you can make a ladder logic to record the minimum and the maximum values of an analog input. I hope you liked today's video. Do share, like and subscribe to my channel and press the bell icon for more upcoming video tutorials. Till next time, take care and goodbye.